Hello dear students, I am Mrs. Tanupreet Kaur Puri, your chemistry lecturer. Today we are going to take a very important topic which is very important from the competitive point of view, be it the NEET examinations or the JEEs. It is valence shell electron pair repulsion theory. ये थ्योरी बेसिकली इतनी इम्पॉर्टेंट है क्योंकि इस थ्योरी की वजह से जो हम शेप्स अपने दिमाग में प्रिज्यूम करते हैं कि मॉलिक्यूल की शेप ऐसी होनी चाहिए, जैसे एक टाइम था माना जाता था कि वाटर एक लीनियर ज्योमेट्री लगता है, मगर इस थ्योरी की वजह से प्रूफ हुआ कि उसकी शेप जो है वो लीनियर नहीं है, तो आप जो प्रिज्यूम कर रहे हैं वो आपका आंसर नहीं निकल के आ रहा है. दिस वॉज एक्चुअली एक्सप्लेन्ड बाय द वैलेंस शेल इलेक्ट्रॉन पेयर थ्योरी. So it stated that in the valence shells there are electrons and they may be exerting certain forces which are responsible for changing the shape and the geometry of the molecule. And as we know that they are bond pairs and they are lone pairs. Now they are categorized into repulsions. अब रिपल्शंस में आप कैसे कैटेगराइज करेंगे? हमने ये देखा कि अगर किसी मॉलिक्यूलर स्पीशी में सिर्फ बॉन्ड पेयर्स हैं तो उसमें मिनिमल रिपल्शंस होती हैं. सो वी से बॉन्ड पेयर रिपल्शन. सो बीपी बीपी. देन वी हैव लोन पेयर रिपल्शंस. दैट मीन्स दे आर more than one lone pair and it is exerting a repulsive force, and they can be a force of repulsion between the bond pair as well as the lone pair. So bond pair, lone pair repulsion. Now these repulsions, are they same? It is seen that the lone pair repulsion is at the maximum because these are non-bonded electrons, therefore they are free electrons, and free electrons as a result are having lot of repulsive force on each other. So we find that the lone pair repulsion is greater than the bond pair lone pair repulsion, which is greater than bond pair repulsion. So the bond pair repulsion is the least. It is because all the electrons in it are involved in the bond formation. There are no free electrons, and here there are only free electrons, therefore the repulsions are very very high. अब एक सिंपल एग्जाम्पल देखते हैं. जैसे मेरे पास एक मीथेन मॉलिक्यूल है. मीथेन मॉलिक्यूल में ओनली बॉन्ड पेयर्स हैं, एंड when the number of bond pairs are 4, the geometry we are getting is the tetrahedral geometry. The bond angle in tetrahedral geometry is 109 degrees. Now the question arises is, why didn't I arrange like this? Why I had to bring it in this format? The reason is simple. It is having only the bond pairs, and the bond pairs try to place themselves as far apart as possible. यहाँ पर आपका 90 डिग्री एंगल बन रहा है एंड इस पर आपकी रिपल्शन ज़्यादा होती, तो बॉन्ड एंगल्स अपने आप को या बॉन्ड पेयर्स अपने आप को ऐसे अरेंज कर लेते हैं जहाँ पे रिपल्शंस जो हैं वो आपकी मिनिमाइज हो जाए. सो दिस इज हैविंग अ टेट्राहेड्रल ज्योमेट्री वेयर द नंबर ऑफ बॉन्ड पेयर्स आर 4. नाउ कैन देयर बी एनी अदर एग्जांपल वेयर वी कैन quote that they are bond pairs? Yes, there are many examples. Now suppose, let's take a complicated example. We have got PCl5. It has got 5 bond pairs, and when we look at the bond pairs, the shape it acquires is trigonal biapyramidal. The phosphorus is in the center, so trigonal, a pyramid goes up, a pyramid comes down, so the shape becomes trigonal biapyramidal. And hybridization, I have already taught you as to how to calculate the hybridization of PCl5, so this is a bit interconnected. Then in the same way, we take another example, SF6. In this, there are 6 bond pairs, there are no lone pairs. So the bond pairs will try to arrange themselves in such a way where the forces of repulsion are minimum. One thing I would like to tell you over here, this is a very important example. Why so? Because there are 2 kind of bond pairs there. The equatorial bond, which are making up the equilateral triangle, and the axial bond. And the best part is the bond length of the axial and the equatorial are not matching with each other. It is seen that the axial bonds, these are the axial bonds, are far more reactive than the equatorial bonds. They are subjected to attacked by the attacking species because the bond length is very, very large. And this is the bond length. You can see here the bond lengths are specified over here. Now in case of SF6, the sulfur is in the center and it is arranged in an octahedral geometry. Very often children get confused with the word octa, that is 8. It is nothing to do with the word 8. It is simply a geometry, octahedron. You have got a square planar geometry in the center. All the fours F are joining up, all the fours F are joining down, and you will get a shape of a regular octahedron. So this is the number of bond pairs are basically 6 over here, nothing to do with the number 8. So octa word 8 से मत confuse होइएगा. सो हमने देख लिया यहाँ पर 4 वाला जो है, हमने यहाँ पर 5 वाला बॉन्ड पेयर्स देख लिया, हमने यहाँ पे 6 वाला बॉन्ड पेयर्स देख लिया. नाउ लेट्स सी इफ देयर इज एनी अदर एग्जांपल. लेट्स सी द एग्जांपल ऑफ BF3. Now boron is basically forming 3 bonds with the fluorine and the bonds are arranged in this way. And if you look at the bonds, it is triangular planar. It can be drawn on the plane of a paper. It's a triangular planar and the bond angle is 120 degrees. So there are 3 bond pairs, again no lone pair. Another example, let us see if there can be any linear geometry. If I have got BeCl2, so I can place it like this. The bond angle is 180 degrees. So these are the examples where we are having only bond pairs, and you can see here there is no lone pair over here. So the repulsions exerted are only between the bond pairs, and the bond pairs tries to arrange themselves in such a manner where the forces of repulsions are minimized. Therefore, they try to acquire the best possible simplest geometry. Thank you. Other updates and learning, you kindly subscribe my channel and press the bell icon. Thank you so much.